Hi everyone, in this lecture we will illustrate Trampoline operating system. Trampoline is an open source operating system written in C and is based on OSIC physics with real-time constraints. Its API is aligned with the OSIC physics OS and the AutoZar OS version 4.2 standards. It is a static RTOS for small embedded systems. This means the objects of the application, tasks, events, resources, and so on can be created or deleted during the execution of the application at the runtime. All objects are statically designed, and instead of forcing the user to describe the application in C, a specific language is used instead, which is OIL. And to compile this OIL file, a compiler is used, which is GOIL. GOIL is used to translate the description in the equivalency programming language structure. It's also perform verifications. Trampoline runs on the following platforms. So if you are a student, you can try using it at your graduation projects based on AVR 8-bit microcontrollers or ARM Cortex M3 or M4 microcontrollers. Okay, at our project we will apply on ARM Cortex M4 processor, which is STM Sirto F4 discovery board. Okay, but before compiling and running our first application, a few tools are required. The first tool needed is a development chain, compiler, and linker for the target platform. In our case, we will apply on ARM Cortex M4 processor, especially the STM Sirto A407 discovery board. You can download the ARM toolchain from its website, or you can download it from the resources section at our course. The two other tools are GOIL and Viper that will combine. Okay, be careful that all paths are relative to the Trampoline root directory. So when setting up path environment variables, complete the relative path with the installation path of Trampoline. Now to compile GOIL. GOIL is located in the GOIL subdirectory from the Trampoline root directory. To compile GOIL, go to the directory corresponding to your operating system. GOIL /makefile -Mac OS X if you are a user for the Mac OS X, okay? Or if you are using Linux or Unix, you can go for GOIL /makefile -Unix. But if you are a Windows user, you can check the project created as a GOIL folder, and you can open it using the code blocks and click compile. Okay, it will generate two executable files which you need to add them to the system path. Okay, after that you need to type ./build.py release. If everything went well, a GOIL executable is generated. You can also compile it, as I said, using the CodeBlocks IDE by opening the project and build it, which will give you these two executables. After that, you need to add this executable to the system bus, and you can test it by typing GOIL --version at your command line prompt. At the time of writing the command should output, okay, 3.19, okay, and no warning, no errors. Okay, if you are a Linux user, so you need to refer to the Trampoline user manual to continue compiling Viper. Now, after compiling the GOIL, we have GOIL.exe and GOIL-debug.exe, and we need to add this path to the Windows path, okay, to the system Windows path. Okay, the next important tool we need to install is the STM32 ST-Link utility. We will use it to detect and flash our discovery board. So you need to open the ST-Link after downloading it from the resources section at our course or from the ST website, official website. After downloading it and installing, you can click target and click connect to connect your PC to the discovery board, okay? And you just need to click file and open file, then select your bin file, okay? After building, we will check this in the next lecture. And after that, you can click target and place program, okay? So we will do here example bin with this is our program. We need to flash it, so we will click target and program. Here you have a check reset after programming. If you uncheck this, so after start programming, you will need to click the restart button at your board, or you can do it automatically after programming your board, okay? Thanks and see you in the next lecture.